All right, so welcome to Earth Science, everybody. Why would we practice free throws or anything for that matter, right? But free throws I picked this morning because I found this little graph, nice and easy. Why would you practice them? Think to yourself. I'd say it's to make more shots, right? Make more foul shots. As it turns out, according to this study that I found, the more of them that you take, the higher your percentage gets. So you shoot more, you make more. That's why we practice things, right? So if we look at this graph here, this is going to be the key to where we actually start talking about some earth science. As we look at this graph here, this shows us that as one thing goes up, the other thing goes up. And that's what we're trying to get at today is relationships in earth science. There's going to be many times throughout the rest of the year until we get to June where a question is going to say, identify the relationship between this and this. Earth science is all about this, like with I don't know, seasons. As the sun's up for a longer time, what happens to temperature? Right? There's going to be things like that all throughout the course. And they're going to get a little harder. There are going to be times where you get this question and maybe there's a vocab word you don't quite get here and another vocab word you don't quite get here. So my goal with this little mini lesson is to say, let's just understand what they're asking when they say this. When you see this, identify the relationship between. That's why I put this big box over it to say, like, there's the question. Then all our job is to say, how does this thing, the first thing that they're asking, affect the other thing? How does one affect the other? And again, these like cause and effect relationships pop up all over this course. So I say today, let's agree upon one standard way in which we're going to answer all of these. And that is to always start with as. The first word will be as. And then start working on your two things. So the first thing they're asking us to compare is free throw attempts. So that's where we start. Start with the word as. Free throw attempts. Change. So you have a little bit of a choice here. You can say increases or decreases. I think it's easiest, and specifically with this one, to start with increases. So as free throw attempts increase, what does that do to the other thing in the question? What happens to the number of shots made? So as free throw attempts increase, shots made do what? This is where you'll have to use your head and say, how does this thing increasing affect this thing? Now, we covered it up here. The more shots you make, the more shots that you attempt, the more you tend to make. So that also increases. There you go. There's your first of many relationship questions. Again, the goal today is just to get a format. So, yeah, let's do some more. If this is asked, another easy example. If you have an hourly job where you have you get this many dollars per hour, and you were asked to identify the relationship between. So there it is, right away in your head. We got to get used to the idea of saying, okay, this means to compare the two things and start with as. I lined it all up for you on this one. As, the first thing, hours worked does something, money earned does something. There's your like skeleton. Every one of them should look exactly like that. So as hours worked, let's go with increases. You work more hours, that means the amount of money you earn is also going to increase. All right, let's think about this a different way. What if the hours worked decreases? For this first part, you get to choose what you're talking about. Do you want to talk about as the first thing goes up or the first thing goes down? They can both be correct answers, but we got to be careful what we say over here. If hours worked increases, money earned increases. What happens if hours worked decreases? Well, in that case, the money earned decreases. I think that's obvious, right? I don't think we're learning anything about money here, but again, the format is what we really want to focus on. Then we're going to go and make you think about it graphically. So we'll complicate life even more. Let's blow this up a little bit. So what I like to do on these, especially while you're figuring it out, while you're a rookie here, and this is literally what I would do when I was taking these tests, like in earth science, because the course has always been about relationships, even when I took it in the early 90s, early to mid 90s. I'd go like this. What if we have low hours, just like every graph, almost every graph, we go from low to high, right? So low hours over here up to high hours over here. I'm not going to worry about any numbers. I'm just trying to get the concept. Money, the y-axis is going to kind of work the same. The low values are down here up to the high values up here. And then I step back and I look at it and I just take a minute to think and understand what I already wrote up here. If I work a low number of hours, I'm here on the x-axis, I'm going to get a low amount of money. I'm here on the y-axis, and I'll just chuck a point for a dot. If I work a high number of hours, I'm going to get a high amount of money. So high on the x-axis is also high on the y-axis. And that's it. So generally, my graph looks like that. A lot like this foul shot one did up here. Sorry. As this goes up, this goes up. So your graph generally has that trend of going up. Cool? All right, let's try another one. What is the relationship between your speed? So again, what's the relationship? Boom, start with S before you even read it. Between your speed and the time it takes to get somewhere. So let's do it. As speed, and then you pick increases or decreases. I'll go with increases. Speed increases halfway there. What does that do to the other thing in the question? The time it takes to get somewhere. If I'm going faster, it takes less time. So in that case, it decreases. So the example I used in class was if I had to get from here, this high school, to the elementary school, and I walked, it would take some amount of time. If I got on a bike, I'd be going faster, so it would take less time. And then if I got in a car, I'd be going even faster, so it would take even less time. That's the relationship. The faster I go, the less time it's going to take. So let's graph that. It's going to look a little different. ETA stands for estimated time of arrival. How long does it take to get somewhere, right? Think of the same thing. What if I'm going for a low speed up to a high speed? What happens to my time values going from low up to high? So if I'm going a low speed, it's going to take a lot of time. It's going to be a high value of time. Whereas if I go a high speed, it takes less time. So graphically, this one looks like that. Those are the basic two that you're going to see in neuroscience for the most part. Either the two variables, one increases the other, that's what this graph looks like, or the two variables, the one going up decreases the other. That's what this looks like. Note on the side, occasionally, you don't have to write this. We'll see some where, this is very rare, where one thing doesn't affect the other one at all. In that case, it's a flat line. You won't see those very often at all. You won't see any of those on today's worksheet, just so you know. The other one that we'll get into when we get into cycles is as one thing goes up, the other thing goes up and down and up and down and up and down. So like take increasing time versus tides. They go low, high, low, high, low, high over and over again. That's a cycle. Those a little more complicated. So don't worry about those today. Let's just do the basic two that show up over and over and over again. All right, in class, I had everybody stop. I stopped talking to everybody's great relief and had everybody write these ones out. So I think you should do the same. I'll press pause too. You press pause, try those 5 right now. Ready? Pause. All right, and if you're back, here's what I would say for these. Let me blow it up a little bit too. Identify the relationship between temperature and the number of coats worn to school. A lot of people today decided to go with this. And again, it's 100% you can do this. It's legal. Let's underline the two things we're looking for, though. I'm looking for the effect of temperature on number of coats. So in writing, as, always start with as, temperature, people wanted to go with decreases on this. Great. That's legal. As temperature decreases, the number of coats increases. There you go. Or if you wanted to say as temperature increases, that would mean the number of coats decreases. They both say the same thing. Graphically, that's your inverse relationship, indirect relationship. That's going to be like that. Because as one thing goes up, the other thing goes down. Identify the relationship between vaccines and incidence of disease. As vaccines or vaccinations increase, incidence of disease decreases. Vaccines, more vaccines would be less of that disease, right? Again, an inverse relationship, going to be like that. Identify the relationship between hours of video games played and thumb soreness. So you're going on a binge, rocking the PlayStation until your thumbs get really, really sore. So that would be as hours of video games played increases, thumb soreness increases. So there we got, as one increases, the other increases, or you can do decreases, right? But that's a direct relationship. Both affect each other positively in the same way. That's your increasing graph. All right. Getting it? I hope. Come see me if not. Because this question, again, we're trying to get the format today. This question, though, will pop up over and over and over again with all the scary vocab we got to learn. Here's some earth science vocab. This is a great website. It's linked on the MP1 survival guide thing. But there you go. Once you get down to 300 something different vocab words. So we got to have the relationships between a lot of these. So yeah, it's going to come up over and over and over again. What about pesticides used in the amount of organisms in a nearby pond? Like an ecological question. If there's lots of pesticides and the water lands on that as rain and drains down to the ponds, what's that do? As pesticide use increases, amounts of organisms decreases. Beautiful. In Monopoly, identify the relationship between the number of houses and hotels and that your opponent has and your chance of winning. So as my opponent gets more hotels / houses. Now, let me take that back. Let's stick to the same format. As the number of houses my opponent has increases, the chance of winning decreases. Which is, again, I guess I did 4 of these in inverse relationship. As one thing goes up, the other thing goes down. All right. Homework. This page, you can either come get from me, or you could just kind of make on your own. Just grab a sheet of paper and do one. Anything you want. It doesn't have to be science related. Something in your life that you can come up with how one thing affects another. They're all over the place. There's no way you can make it through like a whole day of doing things without noticing that this affects the amount of this. So chuck one on there, make it up, and then draw what that would look like graphically and throw that in the hand-in bins right here behind my computer monitor. Again, if you need a copy, see me. Otherwise, you can just make your own. Sound good? Thanks, everybody. We'll see you soon.